Hello, in this video we're going to look at the general beta distribution and then find the mean and the variance of it. Now, one note is that this should not be mistaken with the distribution which is often called a generalized beta distribution. That's a crazy distribution with a lot of parameters and has maybe 20 or 30 different limiting and special, or the generalized beta distribution limits to 30 different types of distributions, or has special cases that go to a special distribution. This is more like just a regular beta distribution that's been extended from A to B instead of 0 to 1. So first let's prove that it is a PDF, and so we want to integrate it over all possible values. And here's our substitution. Y is equal to x minus a over b minus a. The derivative becomes this. We can back solve for x, which would be this piece. And we can also solve it for 1 minus y. And we need to do this because, well, later on you'll see. And so that's why I put an asterisk here. This piece here is, so if we take out alpha minus 1 of them, see, then we have x minus a over b minus a raised to the alpha minus 1. So that's this piece. And then the b minus a, so if we take, there's beta left, so let's subtract one more and add one more. And the add one more we'll put with this, with the dx, so we can have a dy. But then we also get b minus x over b minus a raised to the beta minus 1. So that's where the 1 minus y will come into play. And then this piece right here will come into play when we're looking at the mean and the expected value of x squared. So we plug in this for here and we get this, and we plug in this piece to here and we get that, and of course the dx. Well, now this looks like the common beta distribution that we know from 0 to 1. And we know it integrates to 1. And I have a video called The Mean and Variance of a Beta Distribution, that if you want more specifics to how to show that this does integrate to 1. Or you can just know that this does, and that's good enough. So the mean, what we do is we stick in a x value times the density, integrated over all possible values. Now this substitution we're going to pass back to this. So the y and the 1 minus y will be the same, but this x piece right here, a plus y times b minus a, we're going to have to plug into right here. And so when we look at this next step, that should be 1 minus y, not 1 minus beta. These end up being the same, but we have this extra piece here. So now when we multiply this piece into there and this piece into here, we get this. And so the a is constant, comes out front, and then we just get the integral of this distribution, which is 1. So we're left over with just a. And this piece here is like b minus a times the mean of y. And so that's the mean of a beta, which is this piece. So we have the a, the b minus a, times the mean. Now if you want to look at that video, mean and variance of a beta distribution, you can figure out how that we get the mean of alpha plus alpha over beta. So this is it. So there's the mean. So now to find the expected value of x squared, we stick in an x squared times the density and integrate. And so we use the transformation that we did earlier, and the y and the y minus 1 and the dy are straightforward. This one we have to plug in the x that we solved for. Then what we'll do is we'll expand this, quadratic into this, and then we'll pass this into each of those, and it's the same as before. We get a squared from this one because the rest is the density and it integrates to 1. And then this piece ends up being, 2a b minus a expected value of y. And then this one is the expected value of y squared. Oh, and y is this beta distribution. So now we know from that video, mean and variance of a beta, that that the mean is alpha over alpha plus beta, and this expected value is this. Now once we have this piece, we can calculate the variance. And so the variance is through this formula. And so here's the expected value of x squared, and here's the mean squared. Now to simplify this, what I like to do is to expand this quadratic. And notice that this a squared is minus, will cancel with this one. And then we get 2 times a times this, but then it becomes negative and it cancels with this piece. So we're left over with this minus this squared. And that's what we get here. Now to simplify it, I want to factor out what I can. So we can factor out a b minus a. There's an alpha. And there's a alpha plus beta common in both terms. So it's factored out, and this is what's left over. Now when you get subtract this fraction, get common denominators and subtract, and then simplify, you get this. And it should be noted that when a is 0 and beta is 1, so it's sort of like the standard beta distribution, that would be the variance that we get. Okay. Well, that's all I have for today. Hopefully you enjoyed it. If you did, please like it and subscribe so you don't miss the next one. Thanks. Bye.